Hi class, we are doing the Unit 18 review over here, and we will try to do it in 2 videos if necessary. So first thing it asks for is for us to find each trig ratio in this triangle. Now you'll notice the trig ratios involve 3 different sides, the O, the A, and the H. And in this case, where we have 2 sides, we don't have the third side. So how do we find the third side? Well, luckily we have the Pythagorean theorem that helps us do that. And given 2 sides of the triangle that are the legs, not the hypotenuse, we can sum and square them. 16 squared plus 30 squared under the radical. So if we plug that into our calculator, square root 16 squared plus 30 squared, we get 34. So that side is 34. Okay? So with that, we have all 3 sides. We can come up with the 3 ratios. And we just have to remember I like to put that in there, TOA. And then the reciprocals are on the opposite side. Now, this should say cosecant, secant, and cotangent because, oh, never mind. We didn't learn those. I'm so sorry. I didn't mean that. Anyway, we're looking at 2 different angles. So sine of r. So now we're looking at r. And from r, we have an opposite, adjacent, and a hypotenuse. So make sure that you plug those, label the sides, each side of the triangle. So the sine of r is going to be opposite over hypotenuse, which is 16 over 34. And that simplifies. You can divide out a 2 and get 8, and a 2 and get 17. So 8/17. Now for the cosine, cosine is adjacent over hypotenuse, so that's 30 over 34. And again, you can divide out a 2, and you get 15 over 17. And then your tangent r is opposite over adjacent, TOA, opposite over adjacent, so 16 over 30, and that simplifies to 8/15. Okay? Woohoo! All right, so now sine q. So we're going to take away all of our angles that we were dealing with. Hypotenuse stays the same, but the O and the A might change. Well, they will change. And now we're dealing with angle Q. This is our angle in question. So this becomes 30 is our opposite side and 16 is our adjacent side. And the hypotenuse is still the same. So sine of Q is opposite over hypotenuse. So that makes 30 over 34, which simplifies to 15/17. And then cosine of Q, cosine is adjacent over hypotenuse. Adjacent, where'd my A go, is 16. Hypotenuse is 34, so that simplifies to 8/17. And then our tangent Q, tangent is opposite over adjacent, so 30 over 16, divide out a 2, and you get 15/8. All right, so that's number 1. Moving on to number 2, it asks us to find the value of x, which is this side length here, which is from the angle, the opposite, and we have 9 as the adjacent side. So opposite and adjacent. Opposite is tangent. Remember TOA? So we'll do tangent of 54 degrees is equal to our opposite x over our adjacent 9. Right? And at that point, we have to multiply by our 9 to undo that. So we're solving for x. X is 9 tangent 54. So 9 tan 54 in our calculator is 12.4 units. Okay, so that's how you solve for a side. Remember that we label O's and A's and H's, whichever the 2 in question are, and then you figure out which of the trig functions, sine, cosine, or tangent, should be applied depending on the 2 sides that you have. And then you write up your equation, and then after you write your equation, then you solve for x and then plug into the calculator, and that's how you solve for a side. So on 3, we're looking for x here, which is the hypotenuse. Okay, with our angle, 24 is opposite that angle. If we look directly opposite 46, we have 24, and that is O and H, which is sine. All right, so sine of 46 is equal to our opposite 24 over our hypotenuse x. Now remember, when x is on the denominator, in order to solve, a quick solveroo is switching the sine 46 with the x. which makes x equal to 24 over sine 46. So 24 divides sine 46 is going to be approximately 33.4 units. All right, so that's awesome. That's number 3. Moving on, all right, to number 4. We have numbers 4 and 5. We're looking for an angle now, this angle. Remember, with our angle, we still label sides. We, at that point, find our equation. It's not really an equation, but we figure out our trig function, and we write up the inverse of that trig function, and go from there. We don't have to solve, so they're a little bit easier. So this side here is 24 is our hypotenuse, and 23 is our opposite leg. So that's O and H, just sine, for SoCatel, remember, sine, but because we're looking for the angle, we use the inverse of opposite divided by hypotenuse, so 23 over 24. And we're all solved. We just have to plug that in the calculator. Second sine, 23 divided 24 is 73.4 degrees. Okay, not too bad. X degrees here, we have hypotenuse, and this side runs right into the angle. It's the leg that runs into the angle, so it's adjacent. And AH is cosine. So we have cosine inverse, since we're looking for the angle of the adjacent side, 17, divided by the hypotenuse, 18. So cosine inverse 17 divided 18 is 19.2 degrees. All right. Okay. Next up, we have number 6, which is an x. Also, we're looking for the side. Right here, it runs right into the angle, so it's adjacent. And then the 21 is the hypotenuse. Now, because we're looking for a sine, now we're looking for an equation. The function, trig function, will be cosine, because that's SoCatel. It's an A and H. So cosine 35 is equal to adjacent x over hypotenuse 21. And this is a multiplier we solve by multiplying by 21. So x is 21 times the cosine of 35 degrees. Plugging that in the calculator, 17.2 units is what x is approximately. Okay. And then number 7, we have a degree again. So this time we're going to use our functions that are inverse functions. We have opposite, 10, going straight across from the angle, and running right into the angle for adjacent, 13. So O and A are tangent. So we'll do tan inverse of the ratio of sides opposite to adjacent, 10 to 13. So second tan, 10 divided 13 is 37.6 degrees. Okay, not too bad. Then we have a few more. I'll see what I have time for. We're at 8 minutes. So number 8, the town park does an outdoor movie night every Saturday during the summer on a large screen. Kate is sitting 36 feet from the base of the screen. So we have a screen here for movie night, and here's Kate sitting 36 feet from the base of the screen watching a movie with her family. If the angle of elevation from Kate to the top of the screen, so remember we have to draw our right triangle, so this is the top of the screen to Kate, is 24 degrees, how tall is the movie screen? So that's where our degree goes, and then the movie screen height is what we are looking for. So this is the screen here. All right, so we have an opposite from the angle. Here's our angle. We have an opposite and an adjacent, right? Opposite and adjacent. So that's tangent. So tangent of 24 degrees is equal to our opposite over our adjacent, h over 36. So to solve now for h, we must multiply both sides by 36. So we multiply by 36, and we have h is equal to the 36 tangent of 24 degrees. And that's 16.03, so 16 feet, right? Yep. 16 feet is the height of that screen. All right, number 9. Max built a skateboarding ramp that is 16 inches high. So 16 inches high, and here's our ramp. And that becomes our triangle. I'm going to write ramp here so that we know that's our ramp there. Okay, so the angle formed by the ramp and the ground, which is right here, is 21 degrees. And we want to know what the length of that ramp is. So that's how you set that up. 16 inches high. Now we have opposite and hypotenuse. This is O, this is H, and that means sine. So sine of 21 degrees, which is the angle, is equal to our opposite over our hypotenuse, 16 over x. Now this is a switcheroo. We go ahead and switch that x with the sine 21. And 16 divided sine 21 is 44.6. And that is in feet, I believe. Oh, no, inches high. So 44.6 inches is the length of that ramp. All right, X. Okay, Sarah sights the top of the Statue of Liberty at an angle of 61 degrees. So here's the Statue of Liberty. Here she is holding her fire thing. All right, so at an angle, she's sighting. So here's Sarah. She's looking up at the top of that Statue of Liberty at an angle of 61 degrees for that triangle. If Sarah is 5, she's standing 166 feet from the base of the statue, but this is saying that she's 5.5 feet tall. So where she's sighting the top of the statue is going to be that triangle right there. And then her height is 5.5 feet tall. Okay, and they want to know the height of the statue. So the height of the statue, and I'm going to do this, is going to be 5.5 plus this side measure. All right, because she's 5.5 feet tall, and at that height, she starts looking, or her line of sight happens to the top of the statue. So you need the 5.5 feet plus this height here, x. We need x plus 5.5 in order to come up with the total height. All right, so this is still 61 degrees in here. We have opposite and adjacent. So we're going to do tangent of 61 degrees is x over adjacent side 166 feet. All right, so we're going to multiply by that 166, and we get x is equal to 166 times the tangent of 61 degrees. All right, and in our calculator, 166 tangent 61 is 299.5 feet. Or what is that in? Feet. And then we need to add that to 5.5 feet. So plus 5.5, and that is 304.97, or approximately 305 feet tall is that Statue of Liberty. All right, well, we're at 13 minutes, and I have 2 more to go. I guess I'll do a part 2 with the last 2. So it'll take a while, and I don't want to rush them. All right, so after this, move on to part 2.